Have you ever gazed into the night sky and wondered, where did it all begin? This is the question that has baffled humanity for centuries, sparking a relentless quest for answers. The stars that twinkle in the distance, the planets that orbit our sun, the galaxies that stretch out beyond the reach of our most powerful telescopes, they all hint at a story far grander than our own. Our universe, this vast expanse of space and time, is a cosmic theater where the drama of existence unfolds. But what set the stage for this grand performance? What was the first act in this cosmic play? This is the mystery that we're going to unravel. From the deepest oceans to the highest mountains, from the tiniest microbe to the most complex human brain, everything we know, everything we are, started somewhere. Today we'll journey back to the very start of it all, the Big Bang. Before the Big Bang, there was nothing, not even time or space. Imagine that, a universe of nothingness. A realm where the familiar laws of physics didn't apply. A world without stars, galaxies, or even the faintest whisper of light. A profound silence, an all-encompassing void. This was the pre-Big Bang era, an epoch shrouded in mystery. It's a concept that boggles the mind, isn't it? The idea of nothingness, a state of no matter, no energy, no time, no space, an absolute zero. Scientists can only speculate what this era was like. All we have are theories, mathematical models, and educated guesses. But one thing is certain. This was a universe vastly different from the one we know today. It was an era of perfect stillness, a cosmic canvas waiting for the brushstroke of existence. And then everything changed in an instant. About 13.8 billion years ago, the universe as we know it was born from a singularity, an infinitely small and dense point. Picture, if you will, the densest, tiniest dot imaginable, a dot so small, so incredibly compact that it defies our everyday understanding of space and size. Now, imagine that within this dot was crammed all the matter, energy, time and space that would ever exist. This tiny, inconceivable point is what we call a singularity. This singularity, in a moment of cosmic drama, exploded with unimaginable force. This wasn't an explosion like any we're familiar with. No, this was an explosion of everything, everywhere, all at once. It was an explosion of time and space itself. This event, the birth of our universe, is what we refer to as the Big Bang. In this cataclysmic moment, the singularity began to expand. But this wasn't a slow, gentle expansion. No, this was a rapid, violent stretching of space. It happened faster than the blink of an eye, faster than a lightning bolt, faster than anything we can truly comprehend. As it expanded, the universe cooled. Matter and energy began to separate, and the laws of physics as we know them began to take shape. Quarks, the smallest particles we know of, began to form. These quarks would eventually come together to form protons and neutrons, the building blocks of atoms. And so, in less time than it takes to draw a breath, the universe went from a singularity, a point of infinite density, to an ever-expanding cosmos filled with matter and energy. The universe was no longer a point, but a vast, growing expanse. This is the Big Bang. It's the moment of our cosmic birth, the start of everything we know. It's a concept that challenges our understanding of reality, that forces us to question our place in the cosmos. The Big Bang is the beginning of our story, the first chapter in the book of the universe. In less than a second, our universe was born and began expanding at a phenomenal rate. In the moments following the Big Bang, the universe was a hot, dense soup of particles and energy. Imagine a cosmic kitchen, where the ingredients of the universe were just beginning to cook. This was a place of unimaginable heat and density, where the basic particles of matter were colliding and combining in a frenzied dance. For the first few minutes, this concoction was too hot for atoms to form, but as the universe expanded, it also cooled. After about 300,000 years, it had cooled enough for electrons and protons to come together and form hydrogen, the simplest and most abundant element in the universe. This was a turning point in cosmic history. The formation of atoms allowed light to travel freely, illuminating the universe for the first time. As the universe continued to cool and expand, gravity began to pull clumps of hydrogen gas together. Over hundreds of millions of years, these clumps grew denser and hotter until they ignited the nuclear furnaces we know as stars. These first stars were massive and short-lived, exploding in spectacular supernovae that seeded the universe with heavier elements like carbon and oxygen, the building blocks of life as we know it. Over billions of years, gravity sculpted these stars and gases into galaxies, spinning cosmic merry-go-rounds of billions of stars. Each galaxy is a unique masterpiece, a testament to the creative power of cosmic evolution. From the spiral arms of galaxies like our own Milky Way to the elliptical shapes of older galaxies, each one tells a story of cosmic birth, evolution, and sometimes death. But the story doesn't end there. Even now, 13.8 billion years after the Big Bang, the universe continues to evolve. Stars are still forming, galaxies are still spinning, and the universe is still expanding. The cosmic kitchen is still cooking. As the universe cooled and expanded, the building blocks of life as we know it began to form. And so we find ourselves in this grand cosmic tale, not just observers, but participants in the ongoing evolution of the universe. But how do we know all this? What evidence do we have that the Big Bang really happened? As with any scientific theory, the Big Bang is supported by a wealth of evidence. Let's delve into two of the most compelling pieces. First, we have the cosmic microwave background radiation, or CMB. This is the afterglow of the Big Bang, a faint whisper of light that fills every corner of the universe. Discovered by accident in 1965 by Arno Penzias and Robert Wilson, this radiation is a relic from about 370,000 years after the Big Bang, when the universe cooled enough for light to travel freely. It's like a baby picture of the universe, showing us what things looked like in those early moments. The CMB is incredibly uniform, indicating that the early universe was hot, dense, and remarkably smooth, just as the Big Bang theory predicts. Secondly, there's the abundance of light elements. In the moments following the Big Bang, the universe was a hot, dense soup of particles. As it cooled, these particles combined to form the first atoms, namely hydrogen and helium. The Big Bang theory predicts specific ratios for these elements based on the conditions in the early universe. And when we look out into the cosmos, we find that these ratios match up perfectly with our observations. We can also see evidence of the Big Bang in the large-scale structure of the universe. Galaxies aren't randomly scattered throughout space. Instead, they're arranged in a vast cosmic web with clusters and superclusters interconnected by filaments of galaxies and vast voids in between. This structure grew from tiny fluctuations in the density of the early universe, which we can see imprinted in the CMB. So we have the CMB, the abundance of light elements, and the large-scale structure of the universe. Each piece of evidence on its own is compelling, but together they form a coherent and consistent picture. This evidence paints a clear picture of our universe's fiery birth, and the universe is still expanding. In fact, it's accelerating. Imagine you're blowing up a balloon, but the balloon is space itself. As you add more air, the surface of the balloon stretches, and the dots, representing galaxies, get further apart. This is a simple analogy, but it helps us grasp the idea of an expanding universe. In the early 20th century, astronomers like Edwin Hubble made a startling discovery. They observed that galaxies outside our own Milky Way were moving away from us. Even more intriguing, the farther away the galaxy, the faster it was receding. This led to the revolutionary idea that the universe was not static but expanding. But how do we know this? The evidence lies in something called the redshift. When light from distant galaxies reaches us, it appears redder than it should be. This is because the wavelengths of the light have been stretched out or shifted towards the red end of the spectrum, hence the term redshift. It's a bit like the change in pitch you hear when a siren moves away from you. The greater the redshift, the faster the galaxy is moving away. In the late 90s, scientists studying distant supernovae made an even more mind-boggling discovery. Not only is the universe expanding, but the rate of expansion is accelerating. It's as if our cosmic balloon is being blown up faster and faster. This led to the idea of dark energy, a mysterious force driving this acceleration. So what does this mean for the future of our universe? If this acceleration continues, galaxies will eventually move away from each other at such speed that they'll disappear from view. The universe will become a vast, dark, and lonely place. But don't worry, this won't happen for billions of years. As we gaze into the night sky, we are witnessing the ongoing story of our ever-expanding universe. So, the next time you look up at the stars, remember, you're not just looking at distant points of light. You're looking at a story that began 13.8 billion years ago. This story, as we've discovered, begins with the Big Bang, a singularity smaller than an atom, bursting into existence, birthing time, space, matter, and energy. In the aftermath, our universe was formed, expanding and cooling, creating galaxies, stars, planets, and eventually, life as we know it. Evidence of this cosmic event is still detectable today in the cosmic microwave background radiation and in the redshift of distant galaxies, telling us the universe is still expanding. These profound revelations remind us of our place in the cosmos, born from a cosmic explosion, living on a tiny planet in a vast, ever-expanding universe. And as we continue to explore, who knows what other secrets the universe holds for us?